Hello there, Wildcats. In this video, you will be learning about the absolute value function. So let's just proceed and do example number 1. We are going to graph the absolute value function. So first question here is, what are the features of the graph of f of x is equal to the absolute value of x? So the first thing that we have to do here is we're going to make a table of values. So I'll just copy that and type in there. There you go. So the first step here is to make a table of values and graph the absolute value function, which is we have f of x is equal to the absolute value of x. And I'm now going to make a table of values. So we have, you can check on the values of x. And then we are going to plug that into the function of x is equal to the absolute value of x. And then our result, after we plug them in, which is the value of x, and then the result of f of x, which is our function. So you can choose any values of x. So I'm going to choose -2, -1, 0, 1, and 2. So if I'm going to plug that in, so the absolute value of -2 is +2. So that you have a point -2, +2. Then the absolute value of -1 is +1. So I have a point -1, +1. The absolute value of 0 is 0. So I have 0, 0 as a point. The absolute value of 1, it's still the same, +1. So I have point 1 and 1. While the absolute value of 2 is 2. So I have 2 and 2 here. So if you will notice here, we have your 0 and 0 point here. So a point located at the origin. This is what we call now the vertex. So the vertex is at 0, 0, which is at the origin. So this will be the turning point of the graph. So I'll just put it here, turning point. And you will notice also that we have have your axis of symmetry, which is located at x is equal to 0. So we will be looking at the axis of symmetry once we graph our absolute value function. So if I'm going to graph my absolute value function, it looks like this. So I'll just graph this. So this will be the graph of our absolute value function, and I already labeled the axis of symmetry, which is at x is equal to 0. And then as you can see, the graph has a vertex, which is at the origin. So this is how it looks like. So your axis of symmetry is at x is equal to 0. So if you will notice on the graph of your absolute value function, the graph has an axis of symmetry which intersect the vertex and divides the graph into two sections or two pieces, so that the image of each other under a reflection. So it can be your axis of symmetry will be your line of reflection. And as you can see here, we have your 1 and 1 will be reflected at -1, 1. And your 2 will be reflected as -2 and 2. If you will if you will be taking up your geometry next year, this will be an example of a rigid motion, which is reflection. In our example number 2, we are going to transform the absolute value function. We're going to compare the graph of g function and your f of x function. So question A, how do the domain and range of g of x is equal to 2, the absolute value of x, compare with the domain and range of the function of x is equal to the absolute value of x. So we'll consider your f of x is equal to the absolute value of x as the mother function. So if I'm going to graph both function, it looks like this. So this is these are now the graph of the two functions. So your mother function there, which is the blue one, which is function of x, the absolute value of x, and the red one is g of x is equal to 2, the absolute value of x. So if you are going to transform that and we are going to compare the domain and the range. So the domain of your f function and the domain of your g function. So I'll just write it here. So domain of your f of x and g of x are the set of all real numbers. So I'll just put there all real numbers. Because the absolute value expression produces only non-negative values. So the range of f is y is greater than 0, and then multiplying the absolute value of x by a positive factor. So in this case, we are multiplying your absolute value of x with a positive factor non-negative 2. So the range of g is also y is greater than 0. Okay, so I'll repeat that. So your domain is all real number, and the range of both f of x and g of x would be y is greater than or equal to 0. So the domain and the range of the function g are the same as those of the function of f. So if you're going to analyze based on the graph, we have your origin as your starting point. So there is no values that went down to your negative portion of the graph. So everything is on the positive portion of y. That's why y must be greater than 0. However, we put the domain for both function. It's because it expanded from 0 goes to the left and to the right. There you go. Now in our next example, continuation of example number 2, wherein we are transforming the absolute value function. So for letter B, how do the domain and the range of h of x is equal to -1, absolute value of x, compared with the domain and range of our mother function, which is f of x, is equal to the absolute value of x. If you will notice here, the previous example, we multiply it with a factor of 2, which is positive. And in this letter B example, we are multiplying now the mother function with a negative factor, which is in this case, we have -1. So if I'm going to graph that, it looks like this. So I'll just move this one here. So if you will see here, the line of reflection is y is equal to, or x is equal to 0. So your x axis, not x is equal to 0, sorry. Your x-axis will be your line of reflection here. Now we're going to write now your the domain. So still your domain, which is the x values, that's right there. So your domain for f and the domain of h are all real numbers. So the set of your set of real numbers. So the domain of f of x and the domain of h of x are still all real numbers. There you go, all real numbers. Why? Because as you can see here, it's extending, your line extending from the origin to the right and from origin to the left. And the range is for your range for f of x is y is greater than or equal to 0. So your range is all the values of y. Okay, I'll just repeat. Domain is the values of x, and then your range are the values of y. So your range for f of x, because it's the blue color graph here, so your range is from 0 and then all positive number. However, because you multiply your mother function by a negative factor, which is in this case it's -1, yields non-positive output. So the range for h of x, because you did multiply, again, you did multiply with a negative factor, therefore your range will be y is less than or equal to 0. So it's here, down here. This is your red graph here. The domain of h is the same as the domain of f. Okay, so they are the same in terms of the domain. However, the range of h is the opposite of the range of f. Okay, again, it's the opposite. So I have here additional example. So how do the domain and range of given h of x is equal to 3/4 the absolute value of x compare with the domain and range of f of x is equal to the absolute value of x? We are going to answer this question. How do the increasing and decreasing section of h of x compare to the increasing and decreasing section of the graph of our mother function f of x? So for us to graph this both function, we have to make our table of values, which is we have to assign values of x, and then we plug into both f of x and which is the absolute value of x, and we also have to plug this into your h of x, which is 3/4 the absolute value of x. Okay, in this case we are not multiplying. Okay, so if I'm going to assign values of x here, so let's say I'll start with -2, -1, 0, 1, and 2. So if the value of x is -2, so we'll just get the absolute value of -2, which is +2. Sorry about that. It's +2. The absolute value of -1 is +1. the absolute value of 0 is 0, and absolute value of 1 is 1, absolute value of 2 is 2. And now we have h of x, which is so we do the same with your h of x, which is 3/4 the absolute value of x. So if x is -2, so it will give us 3/2. And if x is -1, so that will be 3/4, of course. This is 3/4. And of course, if it is 0, then this will be automatically 0. If this is 1, it will be 3/4. And if this is 2, will be 3/2. So basically, you can already, you will notice that in your table, your turning point is again at your, it will be on your origin. So this will be at your turning point, or this will serve as your vertex when you graph them. So if you are going to graph, it looks like this. So this is the graph of our two functions. So the red will be your h and your black will be your f. Now let's determine the domain and the range, and we'll answer the question. So the domain and the range of f of x and h of x are all the same. Okay, I'll repeat that and I'm going to write it here. So the domain, just write it here with the green ink here. So the domain and range of f and h are all the same. So if they are the same, what are the domains? So your domain will be, so the domain will be all real numbers. So all real numbers, so it's the values of x. While your range is, again, there is no negative value there, so your range is y is greater than or equal to 0. So that will be the domain and the range. So it is because the absolute value expression produces only non-negative values. The range of f of x is equal to the absolute value of x is y is greater than or equal to 0. So multiplying that matter function, which is or multiplying the absolute value of x by a positive value, which is in this case it's 3/4, yields a non-negative number. So the range of f of h or h of x is equal to 3/4. The absolute value of x is also, which is the same, y is greater than or equal to 0. So to answer the question here, the increasing and decreasing section of h, so the increasing and decreasing of the function h change more gradually than compared to your f. All right, let's do an application of how we are going to interpret the graph of a given function here. Right.
Jay rides in a boat from his home to his friend's home in a neighboring state. The graph of the function d of t equals 30 times the absolute value of the quantity t minus 1 and 5/10 shows the distance of the boat in miles from the state line at t hours. Assume the graph shows Jay's entire trip. Part A. How far does Jay travel to visit his friend?
All right, so we are going to answer part A first. So how far does Jay travel to visit his friend? So this is the graph of the problem here. So the function is decreasing, and then the function here is increasing. So the minimum distance from the state line is at 0 miles. So your 1.5 will be your turning point. Okay, so Jay began his trip 45 miles from the state line, and then maybe I can type that. Travel towards the state line, which he crossed after an hour. So he crossed the state line after an hour and a half. He then traveled away from the state line and was 45 miles from the state line after 3 hours. He traveled a total of 90 miles to visit his friend. So maybe I can do this one. There you go. So Jay began his trip with 40 miles from the state line, and then towards the state line, which he crossed after an hour and a half. He then traveled away from the state line, and it was 45 miles from the state line. After 3 hours, he traveled a total of 90 miles to visit his friend. There. Right, so for our part B, I'll just move the graph here because we'll be using that, and I'll enlarge that. So how does the graph relate to the domain and the range of the function? So basically, as you look at the graph here, your turning point, which is 1.5, this will be our vertex. So from there is no negative value, so everything is positive. So since Jay's entire trip is 3 hours, the domain of the function, okay, because Jay traveled for 3 hours, right? 3 hours. So the domain, so I'll just write it here. So the domain, I know that you know already how to write compound inequalities. The domain, or the values of x in this absolute value function, is that your t is greater than or equal to 0, because see, there is no negative t here, no negative t, but it must be less than or equal to 3, because the maximum time was 3. Okay, for the section of the domain, t is greater than 0 but less than or equal to 1.5. His distance to the border is decreasing. Okay, so from your t is greater than or equal to 0 but less than or equal to 1.5. So his distance is to the border. Okay, his distance to the border is decreasing. Okay, decreasing distance to the border. I'll just write it here. However, if your t, which is greater than or equal to 1.5 to but less than, I'll remove the greater than or equal here. It must be greater than, including this one. It must be greater than less than 3. So the distance is increasing. So distance to the border, or from the borders, from the border. What does this mean? Meaning your the gap there or the first compound inequality that we have, which is t is greater than 0 but less than 1.5. So j is traveling towards, or j is heading to the border. Okay, but on this inequality, t is greater than 1.5 but less than 3, j is going back, or is traveling from the border. So the starting point is from the border. Okay, so that's the difference. So the maximum and minimum values on the graph are 45 and 0. So the range of the function will be the range of the function, because we are talking about the domain in the first one. So the range of the function must be the distance, or your dt must be greater than or equal to 0, but less than or equal to 45. So that is how you interpret your the travel made by J. Now in our absolute value function, we can also determine the rate of change. So it's the same problem. J rides in a boat from his home to his friend's home in the neighboring state. The graph of the function dt is equal to 30 times the absolute value of t minus 1.5. Shows the distance of the boat in miles from the state line at t hours. What is the rate of change over the interval? So in here, we already they gave us an interval written in an inequality. T is greater than or equal to positive 2, but less than or equal to 2.5. What does this mean in the terms of the situation? So if you will look into that, so the time, and so we can now mark the interval. So if t is greater than or equal to 2, so 2, it's here. So the point here is t is 2, and that is 0, 10. This is 15 to 15. And the other point, which is 2.5, which is this one. So that is 2.5, 2.5, and 30. Again, in looking for the absolute in looking for the rate of change, we are looking for the slope. Okay, so we have to use the slope formula to determine the rate of change from t is equal to 2 and t is equal to 2.5. So we are going to use 2 points, which is the 2 points that we already we determine. So the 2 points would be 215 and 2.5, 13. So we have m is equal to y2 minus y1 over x2 minus x1. So you just determine your x1, y1, y2, x2, and y2. So in this case, I'll just mark them. This is your x1, y1, x2, y2 values. So y2 is 30 minus 15 divided by 2.5 minus 2, which will give us your m is equal to 15 over 0.5. Therefore, our rate of change, which is the slope, is 30. So the rate of change over this interval is 30. The rate of change represents the speed of the boat in miles per hour. Since the rate of change is positive, J's distance from the border is increasing. The boat is traveling at 30 miles per hour away from the border. So that is how you interpret your absolute value function. So If you have any question about absolute value function, I will see you on the live Zoom meeting. Thank you, and see you in the next video.